Hey, welcome back. This is part 2 of the lesson for section 2.1. We've been talking about frequency distributions, and as promised, now I'm going to talk about grouped frequency distributions, how we take a big list of individual numbers like this and organize that list into a frequency distribution. For this particular list of numbers, at least one way we can do that, one way I can organize these into classes, is like this. All of those numbers were somewhere between 1 and 120. If you go back and look at the numbers, none of them were any less than 1 or any more than 120. So if I want to divide them up into different classes, one way of doing that is for the first class to be 1 to 15, the second class to be 16 to 30, the third class to be 31 to 45, and so on. So at least that's one way of doing it, where we have these 8 classes, and then each one of those numbers falls into one of these 8 classes. The frequency tells how many numbers are in each class. So for example, when it says that the frequency of this first class is 11, that means that out of that whole long list of numbers, there were 11 of them that are somewhere from 1 to 15. So any of those numbers that's either a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 15 gets counted in this first class. And it turns out that there are 11 of those. Any of these numbers that's a 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, or 30 would get counted in the second class. And there are 12 of those. And so on. So each of these numbers is going to get counted in one of these classes, and then the frequencies tell how many of them are in each class. Now, there are some other things that we could also show that might also be desirable to have as part of our frequency distribution. We could show the boundaries. Remember, I mentioned that those numbers, those dollar amounts, had been rounded to the nearest whole dollar. The boundaries refer to what range of numbers that would have been before rounding. So if something rounded to a 1, 2, 3, 4, 5, or 15, then before rounding it was somewhere between 0.5 and $15.5. So 15.5 was the boundary, the cutoff point between the first and second class. If you were below 15.5, anything that was less than $15.50, like $15.47, would have rounded down to be in this first class. Anything more than that, like $15.51 or $15.60, would have rounded up, because it's closer to 16 than 15, and it would have been in this second class. So notice how the lower boundary for each class is 0.5 below the lower limit. So if the lower limit is 1, we go down to 0.5. If the lower limit is 16, we go down to 15.5. If the lower limit is 31, we go down to 30.5, and so on. And then the upper boundary for each class would be if you start at the upper limit and go up by 0.5. Start at 15, go up by 0.5, you get to 15.5. Start at 30, go up by 0.5, you get to 30.5. Start at 45, go up by 0.5, you get to 45.5, and so on. And notice that that means that the upper boundary of one class is the exact same number as the lower boundary for the next class. We might also want to show the cumulative frequency for each class. Cumulative means they accumulate, they add up. So that's like a running total. We start with just 11, but then 11 plus 12 would be 23. And then that plus 6 would be 29. Plus 5 would be 34. Plus 6 would be 40. Plus 1 would be 41. Plus 5 would be 46. Plus 4 would be 50. So the cumulative frequencies tell you how many of those data values are up to and including that class. And the last cumulative frequency is always the total number of values you have in all, in your whole set of data. So the first two classes together have 23 data values. The first three together have 29. The first four together have 34, and so on. All 8 of them together have all 50 of the data values. We might also want to know the midpoints of the classes. So halfway between 1 and 15 would be 8. Halfway between 16 and 30 would be 23. Halfway between 31 and 45 would be 38, and so on. And how you can figure that out is if you take the lower and upper limits of a class and add them together and divide by 2, so it's kind of like you're averaging them together, that will give you the midpoint. So 1 plus 15 would be 16, divided by 2 gives you 8. 16 plus 30 would be 46, divided by 2 gives you 23, and that's what's halfway between the 16 and the 30, and so on. And one other thing we might want to include is the relative frequencies. Here these have been rounded to 2 places after the decimal point. Really, if you took 11 divided by 50, that does come out to be 0.22. So actually, there's no rounding necessary. But they've been written as decimals. I could have written them as fractions. 0.22 would have been the same as 22%. And then 12 out of 50, 12 divided by 50 is 0.24, and so on. So let's try doing one of these ourselves. Here are the steps that we go through. Now, to figure out what your classes are, start by looking through your list of numbers and finding the highest and lowest values, and then calculate the range by subtracting the highest minus the lowest. Now, you can either do this by deciding how wide you want the classes to be and going from there, or you can do it by deciding how many classes you want to have and use that to determine the width. Like, remember in the example we were looking at, there were 8 classes and they each had a width of 15. There are 15 numbers from 1 to 15. There are 15 numbers from 16 to 30. There are 15 numbers from 31 to 45, and so on. Notice, by the way, that 15 minus 1 is 14, or 30 minus 16 is 14. So you can't get the correct width by subtracting the limits, but you can by subtracting the boundaries. So like 15.5 minus 0.5 is 15. So the width of a class is how far apart the boundaries are, the upper boundary minus the lower boundary. So if you start by deciding how many classes you want, then to find the width, what the width has to be, take the range that you calculated, divide by the number of classes, and then bump that up to the next highest whole number. Next, you would select a starting point, and usually you want to use the lowest value, the smallest number in your list of data, to be the lower limit for the first class. Then find the lower limits of the other classes by adding the width. Then you can find the upper limits of the classes, the boundaries, then tally the data, and then if desired, find cumulative frequencies, relative frequencies, midpoints. So let's try doing that in this example. In this example, we're back at the vet, and we're trying to organize this list of data, which represents how long the various patients had to wait in the waiting room before they got in to be examined by the vet. So one patient had to wait 28 minutes, one had to wait 12 minutes, one had to wait 15 minutes, and so on. So with this long list of numbers, we want to organize it into a frequency distribution using 6 classes. So remember, we're supposed to look through the list and find the minimum and the maximum, and then calculate the range, which is the maximum minus the minimum, the highest minus the lowest. And then the width would be the range divided by the number of classes rounded up. So can you see what the minimum is? What's the lowest of all these numbers? Oh, there's a 1. That would be the minimum. And what's the maximum? Well, it looks like the biggest number on the list is 28. So then the range would be 28 minus 1, which is 27. And then the width of each class would be 27, the range, divided by 6, the number of classes, which gives us 4.5, but then we bump that up to the next higher whole number, which is 5. By the way, it's good when the width is an odd number because that makes the midpoint come out to be a nice whole number. So it's not absolutely required that the width be an odd number, but it's nice and convenient when that happens. So since 1 is our minimum, that's what we'll start with. We'll make our first class start with 1. So that's the lower limit of the first class. Then the lower limit of the second class would be 1 plus 5, which is 6. Remember, we're using 5 for our width. So we add the width to the first lower limit to get the next lower limit. And then 6 plus 5 gives us 11. And we get the rest of them the same way. 11 plus 5 is 16. 16 plus 5 is 21. 21 plus 5 is 26. Now for the upper limits, if the second class starts with 6, the first class is going to have to end with 5. Notice 1 to 5 does give us 5 different numbers in that class. And the next one is going to end with 10. And once we have this first upper limit, we can add the width to that to get the rest of them. 5 plus 5 is 10, plus 5 is 15, plus 5 is 20, plus 5 is 25. And what's the last one? 30. Even though the numbers don't go all the way up to 30, we do want this last class to go up to 30 so that it has the same width as all the others. Now that we've decided what our class limits are, these are what the 6 classes are going to be. 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30. Now it's time to start counting, going through and finding our frequencies by counting how many of these numbers are in each class. So this video is starting to run a little long, so I'm going to end this one here and come back in the next video and we'll finish constructing this frequency distribution.